Walk through an old harbour, a cathedral roof, or a timber-framed hall that has survived half a millennium, and one question always follows. How did the wood last this long without modern chemicals? The answer isn't mystery or luck, it's oil. Specifically, slow-cured plant and tree oils that medieval builders used not as surface varnish, but as a long-term defensive system against moisture, fungi, and decay. This wasn't decoration. It was survival engineering, refined through centuries of trial, failure, and quiet success. The hook hidden in plain sight in surviving medieval structures. If rain alone destroyed wood, Europe would have no medieval buildings left. What preserved them was a treatment that worked with the structure of timber instead of sealing it shut. Medieval oils penetrated deeply, moved with the wood as it expanded and contracted, and remained chemically active for decades. Modern sealants often fail because they crack, peel, or trap moisture. Medieval oils did none of that. The oil medieval builders trusted was usually linseed, pine tar, or both. The most widespread timber oil in medieval Europe was raw linseed oil pressed from flax seeds. When applied slowly and allowed to oxidize naturally, it polymerized inside the wood fibers, not just on the surface. This created a flexible, water-resistant internal barrier that still allowed vapor to escape. In coastal and forested regions, linseed oil was often combined with pine tar or wood tar, producing a darker, thicker treatment ideal for ships, bridges, roofs, and exposed beams. Pine tar added natural antifungal and insect-repelling properties. It also increased resistance to standing water and salt spray, which is, why medieval ships and waterfront buildings relied on it heavily. The oil and tar mixture soaked into the timber rather than forming a brittle shell. That difference explains everything. Why penetration mattered more than shine or hardness. Medieval builders were not interested in glossy finishes. They wanted wood that could get wet and dry repeatedly without rotting from the inside out. Raw oils penetrated deeply because they were applied warm and, repeatedly. Heating the oil lowered its viscosity, allowing it to wick into the grain. The first coats disappeared completely into the wood. Only later applications left any surface presence. This process reduced capillary action inside the timber. Water could no longer travel freely through the wood's cellular structure. Mold spores, which need moisture and oxygen, found neither in abundance. Over time, the oil oxidized and hardened internally, locking in protection without sealing the surface airtight. How medieval craftsmen applied oil as part of a long process, not a final step. Timber was often oiled before installation, especially for beams destined for roofs, ships, or exterior walls. Freshly hewn wood absorbed oil far better than kiln-dried lumber. Carpenters brushed or rubbed the oil on in stages, sometimes over weeks. Excess oil was wiped away. Nothing was rushed. In shipyards and large building projects, oiling became routine maintenance. Every few years, exposed wood received another thin coat. This wasn't repair, it was preservation. The result was timber that aged slowly and predictably instead of failing suddenly. Now, why do modern wood treatments, struggle to replicate this kind of success? Well, most modern products are really all about speed and a nice, uniform appearance. They dry quickly, form these films, and promise, years of protection without any maintenance. But here's the thing. The problem is movement. Wood moves. And when a modern coating cracks, moisture gets trapped behind it. Rot follows pretty quickly after that. Medieval oils, on the other hand, accepted movement as just, inevitable. They didn't crack because they didn't form those rigid skins. Instead, they aged alongside the timber itself. That's actually why beams treated centuries ago still have sound cores, even when their surfaces appear a bit worn. So, how does this knowledge still apply today, in practical terms? Well, that's something worth considering. Builders restoring historic structures continue to use raw linseed oil and pine tar blends for good reason. Off-grid builders and homesteaders use the same approach for barns, sheds, timber frames and outdoor structures where breathability matters. A practical modern application starts with clean, dry wood. Raw linseed oil, not boiled with modern additives, is warmed gently and applied thinly. The wood is allowed to absorb it fully before the next coat. After several applications, a final mix with pine tar can be used for exposed surfaces. Drying takes time. That patience is the price of longevity. This method works especially well for roof timbers, posts, tool handles and structures that face rain but must still dry between storms. It is not a miracle coating. It is a system that requires respect for time and material. Why did medieval builders trust maintenance over permanence? Well, the medieval mindset didn't expect materials to last forever without care. Oil was reapplied when needed and structures were inspected, quite regularly. This relationship with materials kept buildings alive across generations. But modern construction often abandons maintenance in favour of replacement. The oil-treated beam tells a different story. What the survival of medieval timber ultimately proves, is that rain, rot and time are just relentless. Medieval builders didn't defeat them by force. Instead, they outsmarted them by understanding wood as a living material, even after the tree was cut down. Oil was their quiet ally, seeping deep, hardening slowly, and protecting patiently. If this kind of hard-earned historical knowledge matters to you, go ahead and subscribe to the channel and, share this video with others who believe the past still holds solutions worth recovering. The final siren.